All right, so let's go ahead and take a look at number 1 here. It says find the equation of the linear function that contains these points. So to find the equation of a linear function, you need to find your slope. You need to find your y-intercept. And once you have those two things, you can actually write your equation. All right, so slope. Slope is y2 minus y1 over x2 minus x1. And our points up here are the values we need. So if we just plug those in, we can get our slope. That looks to me like that would be -1, so slope is -2. To find the b value, what you do is you plug in your slope and one of these points into this equation and solve for b. So I'm going to use the point that I circled here. I'm going to plug 5 in for y. I'm going to plug in -2 for x. I'm going to plug in -2 for m because that's my slope. So let's see what that would look like. And as you can see at this point, we're able to find out what the b value would be. So b equals 1. So we have our slope, we have a y-intercept, and that's enough to give us the equation in line, which would be y equals -2x plus 1. You just put the slope and the y-intercept in. Okay, so that's how you do finding the equation of a linear function if you have 2 points. The next question, number 2, asks us, is it increasing or decreasing? And is that basically just has to do with the slope. Is the slope positive? In other words, is it going up? Or is the slope negative? In other words, is the function going down? So in this case, since our slope is negative, the answer is decreasing. All right, moving along. We're going to use this following table to evaluate each expression here. We have a column that represents x's. We have a column that represents the f value at any of those given x values. So, and we also have a column for the g values for each x value. So in this case, we're being asked to find f of 0. So that means the x equals 0, and they're wondering what the f value is at that point, and the answer is 2. For part B, they want g of 1 minus f of 1. So first of all, let's find out what g of 1 is. So we find where x equals 1, and we look at the g value, that's 2. So that's what g of 1 is. And then we're going to find f of 1. Find the x value, and the f value is 3. So 2 minus 3 would be -1 is the final answer there. Part C, f of g of 1. So what we're going to do is we're going to figure out what g of 1 is first. And once we have g of 1, we can find out what the rest of the answer is. So g of 1, we've already said g of 1 is 2. So what I can do is I can replace g of 1 with 2. And now I just need to find out what f of 2 is. So find where x equals 2, and f of 2 is 1. So the final answer is 1. All right. Inverse functions are a little bit weird. This is an inverse function. What we discussed quite a ways back and multiple times afterwards was that if you have a function where f of x equals y, then the inverse function would be f inverse of y equals x. Okay. So what this is then basically is they're telling you to look in the f column for the 1. So there it is, and the x value that goes with it is 2. So why does it work that way? Well, we're working backwards, right? Usually we start by looking for the x value to find the y value, but when you're doing inverse function, you start by looking for the y value and work your way back to the x value. So we find the y value which is 1, and we work our way back to the x value, which is 2. So we'll get to put that to the test here on part E and see if we can do it again. So we're looking for g of f inverse of 0. Okay. So I'm going to find where the y value is 0 and work my way back to find the x value. That's 3. So f inverse of 0 is 3. And then from there, I just need to know what g of 3 is. So now this is normal notation, right? We're not doing inverses. So once again, we're going to start where x equals 3, and then we're going to find what the g value is at that point. So the inverse ones are a little bit confusing, but just know instead of starting with the x, you actually start in the other column and work your way back to the x. All right. Part 4. I don't like that color. Let's do white. So number 4, I'm giving you an absolute value function. Absolute value functions, as you guys might recall, you don't need to write this, but they look like a V shape. And what that means is that you can really think of an absolute value function as a piecewise function. It has one linear function pieced together with another linear function. And so what we can do is we can rewrite them as a piecewise function. And that has some benefits for us when we get to calculus, because sometimes we need to do that in calculus. So let's go ahead and do that. So the first thing you got to do is understand what a piecewise function is. A piecewise function is a function where you have two different parts of the equation, where one part is going to be to the left of a certain value and the other part is going to be to the right of a certain value. And it actually could have up to 3 pieces even. Okay, so the point is I want to find out for this V shape, where is that vertex located? Where does it switch from one straight line to another? Because that's where it breaks off from one equation to another. So to find where it breaks off, what we do is we set this equal to 0. I'm going to add 3 first. And divide by 2. And that's where it splits off from one to the other. Okay. Now, 3 halves, if you guys don't know what 3 halves is off the top here, it's 1.5, right? So for anything less than 1.5, we're going to be on 1/2 of the V shape, and for anything greater than 1.5, we're going to be on the right half of this V shape. So we need to figure out what half we're on there. So what I'm going to do is I'm going to pick a number that's less than 1.5. So for example, 1. If you were to plug in 1 here, right, we get that. Now here's our question. Is the absolute value going to change the sign of that value? The answer is yes. It changes it to a 1, right? So what that tells me is that for anything to the left of 1.5, our 2x minus 3 is going to end up having its sign changed. Now, you don't have to do this for the second one, but just for demonstration purposes, anything greater than 1.5. So let's pick a number bigger than 1.5, like 2, for instance. Notice for that one, it doesn't change the sign of the number. So for anything to the right of 1.5, the 2x minus 3 stays exactly as is. So what I've done is I've rewritten this absolute value function as two linear functions connected at a point. Okay, anything to the left of that point, we have negative. Anything to the right, we have positive. Okay, so that's how you do it. So just to kind of review those steps, we only did that once this year, and it's quite a while ago, so I'm taking my time on this one a little bit more so. But just to review, you're going to set the 2x minus 3 equal to 0 so you can find where the function breaks apart into two different pieces. Then you're going to pick a test point to the left and a test point to the right to see which half is changing its sign, and that one gets a negative in front of it. Okay? And that closes out how to find absolute value as a piecewise function. Let's continue here. Long division, that's another fun one. Okay, so long division. We're going to divide this polynomial by this one. Okay. Now, when you're doing long division, you got to make sure that every term is accounted for. Like, for instance, in this polynomial over here, it starts with a third power, then it goes down to a second power, then a first power, and then no x at all, right? Same thing needs to be true here. So it starts with a second power, but it jumps down to no power. So we're missing an x to the first power here. And so what I'm going to do is I'm going to put 0x. Now the reason why we have to do that is 0x is the same as having nothing there at all. But the reason why we do that is because it allows the like terms to line up when we do this process. So you want to make sure that all your terms are accounted for from the beginning. So sometimes you'll have to do it in only one of them. Sometimes you might have to do it in both. Okay, so it's been a while since we've done this as well, but this one's probably a little bit fresher than the last one. So what we do is we ask ourselves, what do we multiply this by to get that? And the answer is x. And you put that answer up there. Next, you're going to take this x and you're going to multiply it by all three of these. And you put the result underneath. So x times x squared is x cubed. X times 0x is going to be 0x squared. And x times negative 1 is negative x. The next thing you do after that is you subtract everything. And what that means is change all their signs. And then combine down. So what should happen every time is that first term should cancel. The other ones just get combined. So those 4 steps are going to be the same every time. You're going to find what you'd have to multiply this by to get this. Put it here. Then multiply that to all 3, put it here, change all the signs, and combine. All right, I'm going to repeat that process now with what's left. Okay, so now I'm going to ask myself, what do I need to multiply this by to get this? And the answer is negative 4. And once again, I'm going to multiply that by all 3 of these. And then we change all the signs. And then we combine down. Once again, the first term should cancel. 6 minus 0 is just 6. Negative 1 take away 4 is negative 5. As soon as you get to a place where this power is less than this power, then you're done with the process. But the way you write your answer also is a matter for discussion as well. So the first thing we do is we write this part first. So that would be our quotient. the answer from our division is x minus 4. So x squared minus 1 goes into this polynomial, x minus 4 times. But there's a remainder, right? We have a remainder left. So our remainder goes over our divisor. And notice that when I write my divisor, I took out the 0x. In the end, you don't need those zeros in there. We just needed that to keep the like terms lining up. Okay, that's a long and tedious type of problem, but something we got to know how to do. So there it is. Synthetic division. Notice they look the same. They both accomplish the same purpose. Synthetic is a shortcut. Okay, it works faster. So why don't we always do that instead, right? Well, you can't. Synthetic only works whenever what you're dividing by is a first degree binomial. So like x minus 2 or x plus 5 or something like that could work. But if you have like an x squared in there, it doesn't work anymore. So it has to be a first degree binomial for synthetic division to work. But it does accomplish the same purpose. So technically, you could just do long division here and get the same answer, the correct answer. But I want to review with you guys how to do synthetic division because it's a useful tool to speed things up a little bit. All right, so the way that we do synthetic division is you start with a bracket like this. And then what you're going to do is you're going to take all the coefficients off of the one that's being divided. So that would be 1, -4, -2, and 1. So 1, -4, -2, and 1. You'll notice I left a gap in here, and that was on purpose. So let's see why. The same rule applies to these as it does up here. You can't have any missing terms. So you're noticing it goes 4 power, third power, first power. It missed the second power. So we need to put a 0 in that spot because there was no second power. All right, next thing that we do is we take this divisor. So what you're going to do is you're going to take this -2 here, and you're going to do the opposite sign of that -2 and put it out here. Okay, so that's just setting up your problem. So the coefficients from here go here. Don't forget to make sure every term is accounted for. The constant here goes in the front with an opposite sign. That's your setup. Now we're ready to actually do some of the math work here that's going to help us get our answer. So the first thing you do is you bring down your 1. Then you multiply this number times this number, which is 2, right? And you put it here. Then you combine down and repeat. So -4 plus 2 makes -2. So now I'm going to repeat that process. 2 times -2 is -4. Combine down and repeat. 2 times -4 is -8. Combine down, repeat. Okay, but what does that mean? What do we do with that? Well, this number is the remainder. This number is the constant. This number is the x. This number is the x squared. And this number is the x cubed. So our answer is going to be 1x cubed minus 2x squared minus 4x minus 10 plus my remainder over the divisor. So if you take all my lengthy explanation out, it's actually a lot faster. It's a lot more convenient. It's a cool trick. But yes, long division will work. But it's nice to know the shortcut. All right, let's go ahead and take a look at number 7. Okay, so we're looking for the third root of 32 x to the fourth. The first thing you want to do is break these numbers apart into their prime factors. So if you were to break down 32, it would be 2 times 2 times 2 times 2 times 2, and x to the fourth would be 4x's. This is a third root, so we're looking for groups of 3 things that are being multiplied together. So as you can see, I've got 2 times 2 times 2, and x times x times x. So that's a perfect cube root there. So the cube root of 2 is 2. And the cube root of xxx is x. These other ones don't have enough to bring out, so they stay inside. So the final answer here would be 2x cube root of 4x. And that's how you simplify those. All right. Next question, transforming something into vertex form. There's a lot of steps on this process. The goal is I want to transform it from standard form, which is this, into vertex form, which is this. Okay. Now there are quite a few steps to this. It's in your notes if you ever want to look at it, but I'll do it really quick here on the video so you guys can see it. Okay, the first thing that you're going to do is you're going to move this 5 over to the other side.
Name Gentry to the front of the school. Name Gentry to the front of the school.
Like that. That's the first step. So we'll say move the C. So remember when I was talking about this being in standard form, this would be like the A, this would be the V, and this would be the C. We're moving the C term over. The next thing we're going to do is we're going to factor the 2 out of these 2 terms here. Just the 2. So if I divide both of these by 2, I'll use a different color to show my work here. I would end up with x squared minus 4x. Okay. So that would be factor out the a. Okay, the next thing we're going to do is a weird step. It's not at all obvious, it's strange. I'll explain why we do it in a moment. But what we're going to do is we're going to do something called completing the square. Okay, so I'll explain why we call it that as we go, but for now, what is it? How do we complete the square? Well, the first thing you're going to do is you're going to take half of this number, so I'll just put half here. So half of 4 is 2. We can even call it negative 2 because it's a negative 4, right? After that, we're going to square it. Which means multiply it by itself. So negative 2 to the second power is going to be a positive 4. And then we're going to put it in right there. It'll always be a positive. Whether you have a negative here or a positive, because you square it, you're always going to end up with a plus there. Okay? Now that's called completing the square. The reason it's called that is because this is a perfect square trinomial, so that when we factor it, we're going to end up with the same binomial twice. And that means it's a perfect square. So this process helps us pick the perfect number to put here so that this becomes a perfect square trinomial. So we completed the square. And that's that. Now, let's go ahead and move along to the next step. The next step is to fix the balance. So what do I mean by that? Well, I added a number on this side, which means that this whole side now is not going to be equal to this side anymore, because whatever you do to one side, you have to do to the other if you want them to stay balanced. Okay, so on the one hand, it may look like I added 4, so to fix it, we'll just add 4 over here, right? But that's not correct, and the reason it's not correct is because this 4, by putting it here inside the parentheses, it's actually being multiplied by 2. So by putting 4 in here, I'm actually adding 8 to this side, because everything in here gets multiplied by that 2. So what I would need to do to fix the balance is put an 8 over there. So I'll show my work for that. So what we do is we take this number here and we multiply it by the 4. And after we multiply it, we add it over here. So 2 times 4 is 8, and that's what I'm going to put on that side over there. And that fixes the balance. That way, even though I added a 4 over here to complete the square, I can still keep these two sides equal because I added something over here to keep the equation balanced. All right, the next step is to factor. Now you're welcome to factor this however you want to, so long as you know how to do it. But what you get when you factor this is x squared minus 4, I'm sorry, that's not correct, is x minus 2 squared. We can also combine these together here. So negative 5 and 8 make 3. So I guess we could say factor and simplify. Now if you don't know how I got from here to here, I'll show you in a minute, but basically it's just factoring. So now there is a shortcut though, and I'll share that with you in a minute, but for now that's the answer. Let's go ahead and move on to our last step here to complete the square. The last step is to take that 3, which is next to the y, and move it back over to the other side. Now that 3, I'm going to call that k, because whenever something is in vertex form, which is what we're trying to get right now, the number outside the parentheses that's being added or subtracted is called the k. So we're going to move the k. And we do that by subtracting it over. And that gives us our final outcome there. Oops, not equals. It's going to be minus 3 now equals y. And there's our final answer. That's the vertex form for this. So why do we do this? It's helpful for graphing. That's why we do that. Anyway, so if you wanted to see how I get from here to here, I can explain that. And I'll do that on the next slide here before I move on to our last problem. I'll show you the long way, but there is a short way that works. So we want to factor this. So to factor, different people who come from different teachers have different strategies for this. But this is how I've always done it. So I'll share this with you. So you put each of these terms in the box. And then we look for what times what makes the first term. We also look for what times what makes the last term. Bearing in mind, after we fill in our box here, x times 2 is 2x, 2 times x is 2x. These two terms should be able to add up to make the middle, and they would if they were both negative, which means that these two need to be negative. Okay, and so what that means is I end up with this. Now this is why they call it a perfect square trinomial, because when you factor it, you end up with the same factor twice, which means that you can write it as a square. Okay, now there is a shortcut, the shortcut for perfect square trinomials, if you want to save yourself the time, is that when you factor one of these things, it's always going to look like this. The only thing that's going to change is what number goes here. And that number is always going to be half of this one. So that would be a -2. And that's this, right? So that's your shortcut, but that only works for perfect square trinomials, which are created when you do that process we talked about in the last slide called completing the square. We're being asked to graph a quadratic here. First of all, these two numbers make up your vertex, okay? But for this number, you're going to use the opposite sign. So it's going to be -3, but you don't do the opposite sign here, -5. So my vertex is going to be at -3, -5. And then it's either going to be, now this is a parabola because it's a square, right? We know that when you have a square, they're parabola shapes. So it's either going to be a shape that looks like this, or it's going to be a shape that looks like that. And the way you can tell which one it is by this number in the front here. If it's positive, you've got a happy face. If it's negative, you've got a sad face. And ours is negative. So the graph would look something like that. And we're just doing a rough sketch. We're not being real precise here. Just getting an idea. So there it is. And then you got your homework. So you can follow what you did in class today to get that homework done.